Storage. All bitmap images are stored in the computer as a rectangular grid of pixels. The resolution, and I don't mean New Year's resolution, is an image referring to the number of pixels in the grid. Higher resolutions mean that they are more detailed and can be stored in the image. The lack of detail in the lower resolution photographs can clearly be seen in the fine detail of the flower. In practice, resolutions as low as 600 by 400 are rarely used in modern digital photography, unless the image is intended for output on the web, where website developers often use lower resolutions to save bandwidth and reduce download time. Manufacturers of digital cameras usually quote the resolution in megapixels. This refers to the total number of pixels in an image, not the width or height. A 1.2 megapixel image contains 1.2 million pixels, giving a resolution of about 1280 to 960 pixels, which is still relatively low. Many modern cameras have resolutions of 8 megapixels, which is about 3200 by 2500, and 12 megapixels, which is about 4300 by 2800, and 14 megapixels, which is about 4300 by 3200. And they actually still make some that are even higher. Sometimes these numbers do not make an exact multiple of 1 million, in which case manufacturers have the habit of rounding up. Bit depth. In addition to resolution, the bit depth of an image affects its quality. Bit depth refers to the number of bits used to store each pixel in the image. The higher the bit depth, the more colors an image can contain, but the more storage space it will require. A 1-bit image can use 2 possible colors because 1 bit can only have 2 possible states, either 0 or 1. A 2-bit image can have 4 colors because 4 different numbers can be represented in 2 bits, 00, 01, 10, and 11. However, a 2-bit image requires twice as much storage as a 1-bit image. Common bit depths are shown here. The most common bit depth for photographs is 24-bit, also known as true color. In true color images, 3 bytes of storage are used for each pixel. In each pixel, 1 byte, or 8 bits, is used to represent the level of red in that pixel. 1 byte represents the amount of green, and 1 represents the amount of blue. You have probably seen this in action when choosing colors in graphics program. You can adjust the sliders separately for red, green, and blue. Each of those sliders are at 0 and goes up to 255 because 1 byte can store 256 possible values. If you know the resolution and bit depth of an image, you can calculate its storage requirements relatively easily. Width times height times bit depth. You will see that this calculation only gives the maximum storage requirement, but the actual storage requirement is often much lower than this. The standard graphics mode for each category is as follows. For desktop computers, they range anywhere from 640 to 480 to 1600 to 1200. It goes to VGA, SVGA, XGA, and Super Extended Video Graphics Array and Ultra Extended Video Graphics Array. There are 2 standard graphics modes for laptop computers. They are both labeled the same, which is Wide Extended Graphics Array, except for one has a plus next to it, which means it's a little bit bigger. The first one is 1280 by 800, and the next one is 1400 by 900. For mobile phones, we also have 2 categories. One's for common or on older mobile phones, which is 120 to 160, and the other is common for newer mobile phones, which is 540 to 960. This is actually a lot different. The first one in mobile phone category is most likely the older flip phones, and the new ones are like smartphones that have more screen space available on them. For televisions, there are 2 televisions here, a 720p high definition and a 1080p high definition. The 1080p is quite larger.